Hello everyone, good morning and welcome again to our online science class. Today is Tuesday, it's the middle of the week, it's May 12th. How are you doing so far with your online classes? Did you submit all your homeworks, your worksheets to your teachers? That is awesome. So kindly get your course book, your pen and notes with you. We'll need especially the notes for the note taking, especially the important concepts. We need it and you need those notes to easily keep track of your learnings, most especially when you answer your worksheets and your homework. Is going to help you a lot. Trust me with that. So we're going to take a look here with a very exciting topic. But before I reveal it to you, I'm going to give you here some mind-boggling questions that you need to answer. So let's crack the brain out and let's answer this. Are you ready? Let's go. Here's question number 1. So look at those pictures. You have those 4 pictures right over there. What is the word? Time is up. Let's see. These are steel. It's very obvious with these 2 first pictures here. Next question, let's take a look with this one. Look carefully at the pictures. Let's see if you get it correctly. It's very familiar kind of material that you see in your everyday life. So let's take a look. It's aluminum. Next question. What is this word? Look at these pictures right over here. Let's see if you get it correctly. It's construction. So you need these materials for any of the construction processes that is happening. Next question. What is the word? Let's see. It's a factory. And let's take a look with this one. This is the last question. What is it? Time is up. Let's see if you get it correctly. The compass, and you already have the clue right over here. So kindly let me know how much did you get? Did you get all 5? That is brilliant. So what do you think is our topic for today? So we're talking here about steel. We'll start talking here about metals. We're talking here about compass. Exactly. Our topic for today is all about magnets. So we have there 13.1 magnets and magnetic materials. We're going to talk here about magnetism, and we're going to define here what are magnets, what is magnetism. So kindly open your course book in page 162 to 163 for your reference, and we're going to learn here to differentiate between magnets and permanent magnets, and also to analyze the magnetic rule based on the behavior of the magnetic poles. And what are the magnetic poles, what do they do, and how is it related to the magnetic field, which we're going to determine later what is that. So let's take a look with the picture that I have right over there. Look. Oh, that device floats. So why do you think it floats? Exactly, because it contains magnets. It's a no magic for you. So what's a magnet? So a magnet is anything that can attract a piece of material without even touching it. And that's why you can see there that it's like floating. So since we're talking here about magnets, there are 2 terms that I want to introduce to you. We have the permanent magnets in magnetic materials. So just based on its name, permanent magnets, magnetic materials, I want you to identify, I have there the materials A, B, C, D, E, and F. Which of these 6 materials is a permanent magnet or are permanent magnets? Is it A, B, or C, D, E, or F? Or is it all of them? What do you think? How about which of the 6 here is known as magnetic materials? Well, I think you have the answer in your mind. So let's check it out with what I have in here. So these are the permanent magnets. It's the A, B, C, E, and F. And I know that you're really familiar with what are these. And letter D is the only magnetic material that is in here. So what is the difference between a permanent magnet and magnetic material? So based on the pictures that I have here, I want you to take a look with it again. Okay? You can observe what's the difference between permanent magnets and magnetic materials. And let's now identify which of these is a permanent magnet and a magnetic material based on the definitions that I have here and based on the pictures that I have shown to you in the previous slide. So is it A, a material that is attracted by magnets, or is it B, an object that stays magnetized for a long period of time? So you have here the clue, a long period of time, so definitely this is for the permanent magnet. So the answer for number 1 is letter B. In the magnetic materials, obviously, this is the one we just left. It's the letter A. So permanent magnets are the ones which are magnetized for a long period of time. Therefore, it can attract other materials for a long period of time. However, magnetic materials are just any of these materials that are attracted by the permanent magnets. Hence, we call them magnetic materials. So, how would we know that something is a magnetic material? I want you again to take a look with what I have there. I have A, it's a paper clip. B, it's a paper cup with nice drawing on it. C, this is your beloved coin. And D, your clothes, your coat. Look at E. What is E? E are steel, and F, it's an iron nail. So how would you know that something is a magnetic material? So which of these are the magnetic materials? A is the magnetic material, that is correct. E and F are the magnetic materials. So we have here 3. It's A, E, and F. So how would you know that something is a magnetic material? One is it should be made up of iron, nickel, and cobalt. So these are the kind of elements which are always attracted to magnets. B, paper, D are not actually attracted by magnets. Why is that? Because they're chemical components. The elements that are present there is not actually related to steel, so it does not contain any of the materials that we have right over here, iron, nickel, and cobalt, and there's a reason why they are not magnetized. How about letter C? Well, C is your nickel coin, and therefore it's also attracted by magnets. Well, you can try it for yourself if you have your magnet in your coin, but not all coins are actually attracted by magnets. So you would know actually if your coin is made up of nickel because it can be attracted by, of course, magnet. So what makes up the strongest magnet in the world? And you have the short video right over there. So you can see the apple and these 2 blocks right over there are metals which are made up of this kind of material that makes it a strong magnet. So any clue about that? So we call that, actually, this is just a trivia, we call it neodymium. And this neodymium is the one which is used to lift cars, and I think that you have seen that on movies when you want to dispose of your car and there's a big circular thing that that attracts your metal, because your car is made up of metals and iron, so it lifts up. So those are actually made up of neodymium, and neodymium is said to make up, is a metal which makes up the strongest known magnet. So why are magnets useful? One is that because it attracts magnetic materials. It can be used in a lot of ways. I'm gonna leave it to you to identify what are those ways. But which part of the magnet makes it useful? So you have there the 2 ends. This is a U-shaped magnet. So the 2 ends here stands for its south pole and its north pole. So these two poles actually makes your magnet really useful. So I want you to observe the poles of the magnet right over here. And I also want you to compare with the ones that I have here. So just to give you a background, these are the magnets, and you see there the red ones with N, it stands for the North Pole, and the S, which is the blue one, which stands for the South Pole. And the black things here that you can see are the iron filings. And in the laboratory before, I have shown you the iron filings. So I would like you to observe what's happening in here. So let's take a look first with this one. I have here the north and north, which are near with each other. So look at the iron filings here, and look also with what's happening here. So if you look here at the iron filings tends to deflect out. And look here, the magnets here never sticks with each other. However, if we put the iron filings on the ends where the north and south are near with each other, try to see what's happening here with the iron filings. The iron filings tends to be deflected towards each other. And if you look here in the picture, what's happening is that the two magnets are attracted with each other. They go with each other. So what is now a magnet rule? So according to the magnet rule, you need a magnetic force. That's the force that allows metals or other magnets to be attracted with each other. And that's the one which you can see a while ago. So the invisible kind of force that you can see in here, which is identified by the iron filings, look at the pattern, and also with this one, is called your magnetic force. So according to the magnetic rule, opposite poles always attract and same poles always repel. And what are these same poles? It can be north and north, just like this one, or just like the one in the active board, it's south and south. However, opposite poles always attract. That's between north and south, and this is how the magnetic force would look. So since we're talking here about magnets, and magnets have poles, and let's relate this kind of topic with the magnetic material. So can we make this needle, and this needle is a kind of magnetic material, can we make it into a magnet? Again, you would know that that is a magnet because magnets attract magnetic materials and they usually exhibit poles. So I want you to take a look with the questions that I have here. Which pole of the magnet was stroked or scratched to the needle and it will be making a south pole? And what should be done on the needle to create a north pole? So to better understand and to better answer that question, and to prove that if we really can make this needle into magnetic material, I want you to take a look with the video that right over here. All we need to have is a ferrite ring magnets. It's a circular magnet, and I think that you have seen this a lot of times in our laboratory. So we're gonna mark it to associate it with a different pole and just rub it there. So 100 strokes with south pole, and this will decide pole of the pointed end of the needle. So take note that we are rubbing it with the south pole. So what will happen to the pole of the magnet? To the pole of the needle. And we're gonna have this one. So later on, I'll be asking you what kind of device are we using. So there, you have the needle compass now, which is ready. So you have there the north pole, and you have there the south pole. And let's take a look with this one. The second needle stroke with the north pole of the magnet. So we're talking here about the tip of the magnet. Let's fill it in with water, and let's try to see what will happen. Look, it moves now. So the movement here is because these needles are now magnetized. And look at the poles now, okay? You can see that there are now different poles just right over there. So which pole of the magnet was stroked to the needle to make a south pole? If you want to make a south pole, you need to stroke the north pole of the magnet. And if you want to make the north pole of the needle on the needle, you need to stroke or scratch the south pole of the magnet to the needle. So if you're stroking it with the north pole, you're making it the south pole. So it's usually reversed. Why is that so? Because you are making now a traction between the North Pole and the South Pole, and scratching the North Pole into a surface of a needle or a magnetic material will create a south pole. Therefore, it will be attracted with each other. Okay, so because opposite poles usually will attract. So it's not that when you scratch the North Pole, you're gonna make a North Pole also on the needle. It's not like that. Scratching that will change the polarity of the object. So if you're scratching it with the North Pole, it's gonna make into a South Pole. So since we're talking here about that kind of material, it looks like a compass, and I think that you have seen it a while ago. It's a compass. So what material makes up the pointer of the magnet or of the compass? The red pointer of the compass points into which direction, and why does the pointer of the compass moves? These are the 3 guide questions that you need to put into your mind when we'll look into this little experiment that I have right over here. So I have here a small magnet, and this one is your compass, and I want you to identify which one is the North Pole in the compass. Is it the red one, or is it the gray one? So for the magnet, the gray one here is the South Pole, and the red one here is the North Pole. So let's answer the first question first. What material makes up the pointer of the compass? Look, so this will also answer the question, give us the hint on the question, why does the pointer of the compass move? So definitely, just like the example a while ago, this compass, the pointer of it is actually a magnetized object, or it can be also a magnet. So do you think that if this one is south-north orientation, do you think that this one is also south and north orientation? Look at this one. This red one, is it attracted to the gray one? Yes or no? It's not. How about the gray one? Is it attracted to the red one? Yes, it is. So what happens here is that, again, the rule for magnet is that opposite poles attract, similar poles repel. Okay, so this one is the South Pole, so it is deflected, or it is not attracted with, or is it attracted with the red one? Look at this one. Okay, so the red and the red here does not attract with each other. So definitely this one is not north. Okay, the red is the north, so this one is definitely not north. So this one, the gray one, is it attracted to the red? Yes or no? But the red here is attracted to the gray. So definitely that whatever whatever direction that you have here with your magnet is always opposite than that of the compass. So the red pointer always points where? So this one is the north of the magnet. So definitely this one is the southern part of the what? Of the compass. So the red pointer will always tend to move at, so the red pointer will always move, or will always point exactly to the south, and the gray one always points to the north. Now look at this one. This one is the south, and this one is the south. It happens because you have this lines of force right over here. So later on I'll be asking you, what is this line of force for the magnet? So what does the pointer of the compass move? The pointer moves because it is attracted, or sometimes it repels to whichever pole of the magnet that we have. So I want you to take note of that very important concept. So the compass here would always point, the gray one always points to the north, and the red ones will always point to the south. Therefore, if this one is a magnet, the red contains the south, and the gray always contains the gray contains the south, and the red contains the north, because opposite poles attract. So since we're talking here about the compass, and it can point direction on the magnet here, so I want you to observe what's happening here. I have a lot of compass in here, and do you see any patterns? yes, we have a pattern right over there, and I want you to observe the pattern really carefully on what's happening with the pattern. Alright, so watch what will happen. In this kind of experiment, we put iron filings here instead of the compass, and let's compare it later with what I have in here. So let's take a look with this one. This one is there's a magnet right over here, and this one is iron filings, and I want you to take a look really closely to the patterns that is made in here. Okay, I'm gonna pause it just right over there. So look, does the pattern in here similar with here? Exactly, it's similar. So we call this as the line of force of your magnet. So describe the formation of the iron filings. So the formation that is formed in here is that the iron filings tend to surround the magnetic field or the line of force of the magnet. It reveals the line of force or the magnetic field of any form or any kind of magnets. Either it's this one or something else. And the shape form is the magnetic field of the magnet. So since we're talking here about lines of force, so which is also connected to what we call the magnetic field of the magnet. So what is the magnetic field of the magnet? So I want you to take a closer look in here. So we have this compass here. Look at the red ones, okay? And I have here the red ones. Look at this, okay? Look at the direction where the red ones are pointing. Again, this one is the north, this one is the south. So in which direction does the compass always point on the magnet? Always, it points to the south of the magnet. So it's from the north, the direction is always going to the south. So if you look in here, the compass always points from the north going to the south. So since we're talking here that the Earth is a very big magnet, let's confirm it. I have a compass right over here, and the red ones will always point to the south. Okay, so actually the Earth, this one is the North Pole, and this one is the South Pole. So the magnetic North Pole of our Earth is technically the South Pole of a very big magnet, and the magnetic South Pole of the Earth is technically the North Pole of a very big magnet in the world. So that's why we can see here that the compass, the red ones, will always point here to the magnetic North Pole of the Earth. So if you look here on our magnet, the position or the flow of the magnetic field is always from the north going to the south. So what is the direction of the magnetic field? The direction of the magnetic field is always from the north going to the south of the magnet. So which part of the magnetic field is really strong? So to determine that part, I'm gonna go back to this kind of experiment right over here with a lot of compass at the background. So this one is the South Pole and this one is the North Pole. So you can see there are lines. So the more concentrated the line is, the greater is force, or the magnetic field tends to be stronger than that of the lines which are a bit scattered. So which part of the magnetic field is the strongest? Is it the side or is it the pole? Exactly, they're always strongest at the pole. So if you want to use a magnet, you usually use any poles of that because that is where a lot of its force is actually concentrated. So far today we have learned about the magnets, the properties of magnets, the permanent magnet versus the magnetic materials, the poles of the magnet, the magnet rules, as well as the magnetic field. So I know that you're really ready for this. It's a quiz time, and let's test how much you have learned so far. So I have here 5 questions that you need to answer. Please write it on your notes that is with you. So prepare them. If you need more time, you can revise it again. But I think you're ready this time. So let's take a look at question number 1. Name the 2 poles of the magnet that attract. It's the North Pole and the South Pole. Question number 2. These are the imaginary lines used to represent the direction of the compass around the magnet. What is this? Let's see if you get it correctly. The answer is magnetic field. Let's proceed to number 3. The force that pulls the magnet to a steel, or the steel to a magnet. Let's see if you get it correctly. It's definitely the magnetic force. Question number 4. These are materials that are attracted by magnet. Example is this one. Exactly, they are called magnetic materials. And this is the last question. These are the object that stays magnetized for a long period of time. Great job. This is otherwise known as your permanent magnet. So, how much marks did you get? Did you get all 5? That is awesome. So, kindly revise this lesson. Again, if you need more time for it, or if you need any clarification, just message me. So, that ends our topic about this. See you next week. Goodbye, everyone. Have a great day.